Hello everybody. Today we are going to look at how we add and subtract fractions. Last class we did multiplying and dividing. That's a little more straightforward. Adding and subtracting is actually going to be a little bit more complicated. Now I know in your notes you have rules with steps 1, 2, and 3 already showing for you, but before we start adding and subtracting fractions, I just want to do a little bit of review on how we add and subtract things. When we add and subtract, we have to make sure we are adding like terms. And I know you remember from previous math classes, we've talked about these things called like terms before. And in your earliest math classes, when you were adding, you probably started with objects. So for example, if I was going to add 3 oranges to 5 more oranges, because I have like terms are all oranges, I could add those and group them together to give me 8 of those oranges. And if you had things that were not like terms, so I'm just going to write here not like terms, you might have things in your earliest days like maybe you were adding 3 oranges and 5 apples. And because they are not the same kind of thing, we could not group them together. So you could not add them together and say you had 8 of some other things. In fact, when we start looking at fractions, to add apples and oranges together and say you got 8, it would be almost like saying you had 8 potatoes. Obviously not the same thing, so you could not do that. Hence this inequality sign. When we talk about fractions and we're adding and subtracting them, at the same as we did with the oranges and apples and things, we have to be adding like terms. So for example, I'm going to start with example 1 here. If I'm trying to add 5 twelfths plus 7 eighteenths, if I say these out in words, it's easy to see that these are not like terms. I'm going to write this out in words. It might be a little bit easier to see. If we are trying to add, I just said do this in words and then I wrote the number down. So I'm going to say, supposing we are adding 5 twelfths to 7 eighteenths. You can tell because I have twelfths and eighteenths that these are not like terms. So I cannot just add them together and say that I have, 12 of these things. 5 and 7 gives me 12. But then what unit would I use? This would be like trying to add oranges and apples, and I cannot add those denominators together and say I have 12 thirtieths. Not going to work. Sort of like trying to add those apples and oranges. So what we want to make sure we do not do is add those numerators. Do not add numerators and add the denominators. Something we find very tempting to do because it is so much easier than what we actually have to do, and that is get our fractions to be rewritten in like terms. So what I really need to do is take my 5 twelfths and I have to find an equivalent fraction with a different denominator to add to an equivalent form of my 7 eighteenths written so that these are like terms. And when I have fractions that are like terms, they are going to have the same denominator. And my same denominator, best if we used our least common denominator, or LCD is what we used to use in previous math classes. So what we are really trying to do is rewrite our fractions so that we have like terms. And those will have a common denominator. Which we will use as our LCD, or least common denominator. So in your rules up above here, I know that you have yours written in. The first thing we want to do is find that least common denominator so that we can rewrite our fractions. And then we are going to just add and subtract the numerators, keep the denominators, because that's like keeping our units, apples and apples, or oranges and oranges. So let's go ahead and finish this example that we've started. We want to go ahead and complete this sum, 5 over 12 plus 7 over 18. To find that least common denominator for my 12ths and my 18ths, I can use that tree factorization and write each of these as a product of primes. So I'm going back to what we did before. I have a denominator of 12, and I'm going to write that as its product of primes. Let's see, I can multiply 2 times 6, and 2 is prime, but 6 is not, and I can rewrite 6 as 2 times 3. So my 12 is equivalent to 2 times 2 times 3. I'm going to do the same thing for that denominator of 18. Doing the tree factorization, I can multiply 2 times 9. 2 is prime, but 9 is not. 9 can be written as 3 times 3. And I have my prime factorization now as 2 times 3 times 3. So here's now how I'm going to get the least common denominator for my 12 and 18. I'm going to start out with using the prime factorization for either one of my numbers. If I choose the 12, that would be 2 times 2 times 3. Now what I want to do is take a look at the prime factorization for my other denominator, the 18, and I want to make sure that I have a 2, which I do, a 3, which I do, and I need another 3, so I'm going to need to multiply this all by 3 again. And I get for my least common denominator the product of 2 times 2 times 3 times 3, which gives me 36 when I multiply that all together. So the common denominator I'm going to use for my 5 twelfths and 7 eighteenths is 36. So what I'm trying to do now is rewrite 5 over 12 as its equivalent fraction, but with a denominator of 36, my LCD. To do that, I would have to multiply the 12 here times a 3, so I will need to do that to the 5 as well. And I get an equivalent fraction of 15 over 36. Do the same now for the 7 eighteenths. We are rewriting it with that common denominator of 36. To do that, I multiply the 18 by 2, and I do that with the 7 as well, which gives me 1436. So now I'm going to take my original sum, 5 twelfths plus 7 16ths, and since 5 twelfths is equal to 1536, I can add that to 14 over 36, since that is equal to 7 over 18. And now I have like terms because I have the same denominators. 1536 plus 1436 is going to equal, well, how many 36? Let's see, 15 plus 14 is 29. and it's 29 of those 36. Now I need to see if I can reduce this. 29 is a prime number. The only factors it has is 1 and 29. And since 29 is not a factor of 36, I cannot reduce that anymore, and that is my final answer. Now, just to emphasize again why these are like terms, I'm going to write these two fractions out in words again. It's like saying I have 15 36. So this is like 15 of those oranges, or in other words, 15 36. And I'm adding that to 14 more of these 36. These are my like terms. They're both 36, so altogether that gives me the 15 plus 14, or 29 of these 36. Alright, so let's take a look at another example. I won't write everything out in words anymore, so we are just going to go through on this next example and follow our rules. So I'm going to extend my page here. Hope that you have space also on your notes. If not, you might need to add some scrap paper for notes. I am going to do now example, call this example number 2. And let's add 3/4 and 1/6. Now when I see these two different denominators here, I see that these are not like terms. So I need to find a common denominator and rewrite each of these with that common denominator so I can add the like terms. My two denominators, now some of you are going to look at that and say, okay, I can come up with my least common denominator between 4 and 6, but for practice sake, I'm going to go ahead and write the prime factorization for each of these. My least common denominator then is going to be, I'm going to start with the factors for the 4, 2 times 2, and when I look at my factors for 6, I need a 2, which I have here, and I also need a 3, and I don't have that, so I'm going to need to add that as a factor. So now my least common denominator is equivalent to 2 times 2 times 3, which would be 12. So now I'm going to take each of my fractions and rewrite them so that they have that same denominator of 12, and then I will have like terms. To get fourths into twelfths, I would multiply by 3, numerator and denominator, giving me 9/12. To change 1/6, I'd have to multiply by 2, which gives me 2/12. So now I can say that I'm really adding 3/4, which is the equivalent of 9/12, to 1/6, which is the equivalent of 2/12, and now I have like terms. To add all these twelfths together, 9/12 plus 2/12 is going to give me 11/12. I want to check and see if I can reduce that. 11/12 does not reduce, so my final answer is 11/12. All right, let's look at another example, and this time we'll look at a subtraction problem. So I've got some space on the next page. I'm going to do example number 3. And we are going to take 7 over 15 and subtract 3 over 10. Now, since these have different denominators, we have terms that are not the same, or I'm going to write down here, not like terms, cannot just add them together. I need to get a common denominator, and my common denominator will be an LCD. I'm going to go ahead and do this factorization tree for this. For 15, Let's see, that's 3 times 5, and those are both prime, so that's finished. For 10, 2 times 5, and those are both prime, so that's finished. So looking at my LCD, I'm going to take the 15. I know I'm going to need a 3 times the 5. Looking at the 10, I'm also going to need a 2, which I don't have, so I'm going to multiply by 2. And I'm going to need a 5, which I already have, so I don't need another one. That gives me an LCD of 3 times 5 times 2, which is 30. So now I'm going to take 7 over 15, rewrite it as an equivalent fraction with a denominator of 30. Do the same for 3 over 10. Alright, going back to my 7 over 15, I'm multiplying top and bottom by 2, gives me 14 over 30. For 3/10, I'm multiplying numerator and denominator by 3. This gives me 9 over 30. So my equivalent subtraction problem is the 7/15 or 14/30, and I'm subtracting 3/10 or the equivalent of 9/30, which gives me, I'm subtracting 14/30 minus 9/30 leaves me with 5/30. Now this is a fraction that I can reduce. 5 is a factor of both of those, so I'm going to divide each of these by 5. I get 1 in the numerator, 6 in the denominator, for a final fractional answer of 1 over 6. Alright, let's look at one last example here. And we're going to make this a little bit more complicated in that I'm going to combine a couple of things. Actually, we're going to do 2 more examples, so 3, 4, and 5. Let's go and take example number 4. Going to make this a whole number 3 minus 5 6. Now these again are not like terms, because they don't have the same denominator. In fact, the 3 is a whole number. I do want to write it as a fraction, however, so I can do that by just placing the 3 over 1. And I'm going to find my least common denominator to use for my common denominator for each of these. So let's see, 1 and a 6. Well, hopefully most of you can see that the LCD is going to be 1 times 6 or just 6. So I'm going to take the 3 over 1 and write it as a fraction over 6, which means I'm multiplying numerator and denominator by 6 to get 18 over 6. The 5 6 is already in 6, so my new problem would look like 18 over 6 minus 5 over 6, which leaves me with 13 over 6. And we are going to do one final example, a little bit more complicated. In fact, we're going to do some addition and subtraction. I'm going to take 1 over 6, add it to 1 over 8, and subtract 1 over 4. And we are going to use our rules of operations. For adding and subtracting, we need to go left to right in that order. But I have fractions here, so I still need to get a common denominator so that I have all like terms. So my common denominator, I need to break down all 3 of these denominators to get that common denominator. 6 is equal to 2 times 3. 8 is 2 times 4, but the 4 is not prime. It's 2 times 2. 4, 2 times 2, both prime, so we're finished. Let's take a look at how to get this LCD. I'm going to first put down the factors for my 6, the 2 times the 3. And when I look at the 8, I need a 2, another 2, and a third 2. I have 1, 2, but I need 2 more. And when I look at the 4, I need 2 2's, I have one here and another one here, so I have two. That's all I need for the 4. I can go ahead and multiply these out and get my least common denominator, 2 times 3 times 2 times 2. That would give me 24. So that's going to be my least common denominator. I'm going to rewrite each of these fractions so that they have an equivalent form, but with a denominator of 24. Let's take a look at our 1/6. To get a denominator of 24, I multiply by 4 to give me 4 24ths. The 8 I would multiply by 3, so I get 3 24ths. And the 4 I would multiply by 6 to get 6 24ths. Rewriting my problem now, 1/6 is the same as 4 over 24. I'm adding to that 1/8, which is equal to 3 over 24. And then I am subtracting 1/4, which is equal to 6 over 24. Now moving left to right, I'm going to first add 4 24ths and 3 24ths gives me 7 24ths. And then I am subtracting 6 24ths, which leaves me with just 1 24th with nothing to reduce. And so that is our final answer. All right, I hope that makes sense to all of you. Have a great day. Thank you.